Hello. Next thing we're going to do is look at some proofs that deal with perpendicular lines. There are 3 new theorems that you can see on the screen now. We actually aren't going to use these yet. They will come in handy in the future, but I want to talk about these really quick before we get into some proofs, just because theorems and proofs kind of go together. First one is the linear pair perpendicular theorem, which says if 2 lines form a pair of congruent angles, then the lines are perpendicular. So as you can see here, angle 1 and angle 2 form a linear pair, which means that measure of angle 1 plus measure of angle 2 has to equal 180 degrees. However, they're also telling us that angle 1 and angle 2 are congruent. The only way you can have 2 angles add up to 180 degrees and have those angles be congruent is if both of them are equal to exactly 90 degrees. The next one, the perpendicular transversal theorem, says if you have a transversal, which is J in this picture, that is perpendicular to one parallel line, then it's perpendicular to the other line that's parallel to that line. So you can think about this a few different ways, but what I like to think about here is we can call this angle 1 and this angle 2. Angle 1 and angle 2, since we have 2 parallel lines with the transversal, would be corresponding angles. Corresponding angles are congruent if the lines are parallel, which they are, which means that angle 2 also has to be a right angle. Since angle 2 is a right angle, that means J is perpendicular to K. And last of these theorems, lines perpendicular to a transversal theorem, says if you have 2 lines that are perpendicular to the same line, so in this case line M and line N are both perpendicular to line P, then line N has to be parallel to line N. That was kind of a tongue twister. So same idea. I'm going to call this angle 1, this angle 2. Angle 1 and angle 2 are corresponding angles. Since they are congruent, that means that line M is parallel to line N. Now let's dive into some proofs. Again, they aren't going to use the theorems we just talked about, but they are going to involve perpendicular lines. So in this first one, we are given that A is perpendicular to B. They want us to prove that angle 1, angle 2, angle 3, and angle 4 are all right angles. So first things first, we're just going to fill in their statements and reasons like we usually do. The reason for whatever goes in statement 1 is given. What's the only information we were given? We were given that A is perpendicular to B, so that's exactly what's going to go in the given spot. Moving right along. Next statement is that angle 1 is a right angle. How can we say that angle 1 is a right angle? Well, since we know that line A is perpendicular to line B, the definition of perpendicular lines say where those lines meet is a right angle. So this is going to be the definition of perpendicular lines. I meant to switch colors there and I didn't, so pretend I did. Statement 3, well, the reason for whatever that is the definition of a right angle. What does the definition of right angle say? It says that right angles equal 90 degrees. So since angle 1 is a right angle, we can say that measure of angle 1 equals 90 degrees. Might seem kind of redundant, but remember when we do these proofs, we're being very thorough and taking things one step at a time. Next up, angle 1 is congruent to angle 4. How can we say that? Well, let's look in the picture. What relationship do angle 1 and angle 4 have? So they're saying they're congruent, but we can say they are congruent because they are vertical angles. So I'm not going to write the whole thing there. That's going to be the vertical angle congruence theorem. Okay. Next up is whatever we are saying is because of the transitive property of equality. Remember, transitive property of equality says that if A equals B and B equals C, then A equals C. Well, let's see what we know. Right now we know measure of angle 1 equals 90 degrees. Angle 1 and angle 4 are congruent, which is basically the same as saying angle 1 equals measure of angle 1 equals measure of angle 4. So since measure of angle 1 equals 90 and measure of angle 1 equals 4, we can say that measure of angle 4 equals 90 using that transitive property of equality. The next one might feel a little weird. We're saying angle 1 and angle 2 are a linear pair. You might tempt to be say given for that, but technically they didn't tell us that in the given. But we know that linear pairs look like we have what we have going on with angle 1 and angle 2. And in that together, they make a straight line and are supplementary. And so what that comes from is the definition of linear pair. The next reason we are given for what comes next is the linear pair postulate. The linear pair postulate says that angles in a linear pair are supplementary. So since angle 1 and angle 2 are a linear pair, angle 1 and angle 2 are supplementary. I'm going to do a little abbreviating here too. And then very related to that, since two angles are supplementary, we can say angle 1 and angle 2 are equal to 180 degrees. And saying they are supplementary and then saying they're equal to 180 degrees, that's just using your definition of supplementary angles. All right. Now the next one is involving the use of the substitution property of equality. Look back at step 5. Step 5, I lied, not step 5, step 3. Step 3 says that measure of angle 1 equals 90 degrees. So instead of saying measure of angle 1 here, I can say 90 degrees here, and then keep the rest of the equation the same. Replacing 90 degrees with measure of angle 1 was the substitution property of equality. Then next up, we say that measure of angle 2 equals 90. How did I get from the equation in step 9 to the equation in step 10? What I did was I subtracted 90 from both sides. So it means it canceled on the left side. 180 minus 90 is 90. So what I used there was the subtraction property of equality. Alrighty. Getting close to the end here. Next one is involving the vertical angle congruence theorem. What vertical angle pair have we not used yet? We haven't used that angle 2 is going to be congruent to angle 3 because they're vertical angles. So we can say that measure of angle 2 is congruent to measure of angle 3 by the vertical angle congruence theorem. Very similarly to what we did back in step 5 with the transitive property of equality, we're going to do that one more time. Measure of angle 2 equals 90 degrees, which means that measure of angle 2 equals measure of angle 3. And since measure of angle 2 equals measure of angle 3, that means measure of angle 3 equals 90 degrees. Same idea as we did before with our transitive property of equality. Last but not least, first of all, what usually goes here in this ending statement was what we're trying to prove in the first place. What we're trying to prove in the first place is that 1, 2, 3, and 4 are all right angles. Leaving out some words there. But how can we say that for sure? Let's retrace our steps. We have that measure of angle 1 equals 90, measure of angle 4 equals 90, measure of angle 2 equals 90, measure of angle 3 equals 90. Since all 4 angles equal 90 degrees, all 4 angles are right angles. So that's it for that proof. A little long-winded, but we did have to take things step by step. Let's try one more shorter proof. This time we are given that ray, remember that's the ray symbol, BA, which is this one, is perpendicular to ray BC, which is this one. They want us to prove that angle 1 and angle 2 are complementary. So first off, they say ray BA is perpendicular to ray BC. That was given to us, so my first reason is just given. What did we say in that first statement? In that first statement, we said that the two rays were perpendicular. When you have two lines, or in this case, rays that are perpendicular, the angle that goes between them is going to be 90 degrees, or a right angle. And so we can say that angle ABC is a right angle, since those two rays are perpendicular. Perpendicular lines, or rays in this case, meet at right angles. Next one might feel a little redundant, but we've got to make that step. Right angles equal 90 degrees, so we can say that measure of angle ABC is 90 degrees. Where does that come from? That comes from the definition of a right angle. Definition of a right angle just says that right angles measure 90 degrees. That's all. Now, the next reason is dealing with the angle addition postulate. Angle addition postulate is saying that this angle, angle 1, and this angle, angle 2, add up to be the whole bigger angle, angle ABC. And so let's just put that into a formula, which, boom, is what we have right here. Measure of angle ABC equals measure of angle 1 plus measure of angle 2. Okay, thinking about our next reason, how did we get from step 4 to step 5? What is different? The only thing that's different is I have replaced measure of angle ABC with 90 degrees. So what I did there is, since measure of angle ABC equals 90 and measure of angle ABC equals measure of angle 1 plus measure of angle 2, I can say that 90 equals measure of angle 1 plus measure of angle 2 using the transitive property. And then last but not least, what were we trying to prove in the first place? That's usually what goes in the last part. We were trying to prove that angle 1 and angle 2 are complementary. But why can we say that for sure? We know that angle 1 and angle 2 add up to 90. Complementary angles add up to 90 degrees. So angle 1 and angle 2 must be complementary. That is it for these perpendicular proofs. I hope you have a fantastic day.